Hi everyone. Today is the fifth problem solving session for the course Environmental Chemistry and Microbiology. The course instructors are Professor Anjali Pal and Professor Sudha Goel from IIT Kharagpur, and I am Shrija Ghosh, a PMRA from IIT Kanpur. I am going to discuss the questions related to this week's session, and I'll try to help you out with the doubts you have. So I've prepared certain questions related to your assignment questions, and we'll be solving the questions together. I request all of you to write the answers in the chat box of each question, and then we can have a discussion if your answer is correct or wrong. Okay. Uh, and let me know if you have any kind of doubt in this session's uh, topics. I will try my best to help you out. Okay. So I will start with the first question. Question number 1. The full form of THM is option A trihydroxymethane, option B trihalomethane, option option B tetrahalomethane, option C trihalomethane, and option D tetrahydroxymethane. What is the full form of THM? Is it trihydroxymethane, tetrahalomethane, trihalomethane, or tetrahydroxymethane? Write your answers in the chat box. Whatever you think is the correct answer, you can write it in the chat box and then we can have a discussion. What is THM? Okay, I have one answer in the chat box. What about others? Okay. Okay, three of you are saying option C. Anyone else wants to answer? Option C, that is trihalomethane. That is the correct answer. THM is trihalomethane. Trihalomethane means there are three halogen molecules attached to a methane. So methane is basically CH4. So you have carbon attached to 4 hydrogens. Okay. So instead of these hydrogens, 3 of the hydrogens are replaced with halogen molecules. So what are halogens? So you have fluorine, chlorine, bromine, iodine, all these molecules on the periodic table. These are called halogens, and 3 of the hydrogen groups, if they are replaced with these halogen molecules, it makes it 3 halomethane. Like if these hydrogens are replaced with chlorine, then you will get CHCl3. If it is replaced with bromine, then you will get CHBr3, and so on. If one of the hydrogen is replaced with chlorine, 2 are replaced with bromine, you will get a molecule CHClBr2. So you can get different kinds of trihalomethanes. Basically, it means that it has 3 halogen molecules attached to a methane molecule. These trihalomethanes are basically compounds that are found in the water sample, and we'll discuss about the water treatment and other topics in the subsequent questions, so you will understand the context of trihalomethane. Okay, moving on to the next question. at what ph at what pH chlorine in water acts as hypochlorite only? At what pH the chlorine in water acts as hypochlorite only? Options are option A less than 5, option B greater than 5, option C greater than 10, and option D greater than 3. At what pH the chlorine in water acts as hypochlorite only? What would be the correct answer? Write your answers in the chat box. All of you write your answers in the chat box and then we'll have the discussion. At what pH chlorine will act as hypochlorite only? Okay, I have one answer. Two. Okay. Two people are saying option B. What about others? Anyone else? All of you write the answers in the chat box. Okay, three of you are saying option B. What about others? Anyone else wants to answer? Option B is not the correct answer. Now, anyone else wants to answer? Okay, I have one answer in the chat box, option C. Anyone else? Okay, option C is the correct answer. So, uh, when we add chlorine in water, it can form either hypochlorous acid, like it can be in a protonated form in the form of hypochlorous acid, or in a deprotonated form where it becomes hypochlorite ion. Okay, so and this relation is pH dependent. So when we keep on increasing the pH, slowly the hypochlorous acid starts decreasing and hypochlorite ion concentration starts increasing. So basically, when we are increasing the pH, that means we are increasing the OH minus concentration. So when the OH minus concentration goes up, H plus will be released to neutralize these OH minus ion concentration, right? So that's why HOCl, that is the hypochlorous acid, it will start releasing the H plus ions, and slowly hypochlorous acid concentration will decrease as the pH increases, and beyond pH 10, 100% hypochlorite ion, that means hypochlorous acid is completely deprotonated beyond pH 10. So pH greater than 10, we'll have only hypochlorite ions present in the water and no hypochlorous acid will be present. At pH less than 5, only hypochlorous acid will be there because it's very low pH. So all the hypochlorite ions will be protonated to form hypochlorous acid, and at pH 5, at pH less than 5, we'll have 100% hypochlorous acid, and at pH more than 10, we'll have 100% hypochlorite ions. Is this clear? Is this clear to everybody? So the ratio of hypochlorous acid to hypochlorite ions is completely dependent on pH. Do you understand how it is dependent on pH? If you have any doubt, you can either unmute your mic or you can write it in the chat box.
Ma'am,
Yeah, you tell me.
could you please explain it once again?
Yeah, sure. So, the when we add chlorine to water, it will react with the H plus ion of the water and it will form hypochlorous acid. But that this reaction is pH dependent, because hypochlorous acid, basically it's an acid. So if you remember from the first class, we had we'll take simple acid example where HCl, if we put HCl in water, it will dissociate into H plus ion and Cl minus ion, right? Similarly, hypochlorous acid can also dissociate into H plus ions and OCl minus ions. But this dissociation, it is dependent on pH. So at very low pH, the H plus ion concentration will be very high. So all the hypochlorite will be protonated and it will be present in the form of HOCl. when we keep on increasing the pH. That means we are adding OH minus ions. Increase of pH means the OH minus ion concentration is increasing, right? So when OH minus ion concentrations are increasing, what will happen? Some HOCl molecules will start releasing the H plus ions to neutralize this OH minus ion, so that the pH is maintained. So basically, if we add OH minus ions so that pH shifts from 5 to 7, what will happen? HOCl will now dissociate into H plus ion and OCl minus ions, and uh, at 7 around 80% of HOCl. So 20% of HOCl will then dissociate into H plus and OCl minus ions, and those H plus ions will be required to neutralize these OH minus ions to form water. Okay. So basically, when you keep adding OH minus ions, HOCl will keep releasing this uh, H plus ions, and after pH 10, it will completely, all the H plus ions will be used up by the OH minus ions, and 100% OCl minus ions will be remaining in the solution. 100% OCl minus. So after 10, pH 11, 12, whatever you will take, you will only find OCl minus ions. There will be no HOCl present. And below 5, there will be only HOCl present. There will be no OCl minus ions present, hypochlorite ions present. Is this clear?
Yes, ma'am. Thank you, ma'am.
Okay, welcome. Anyone else has a doubt, or if you did not understand, I can explain again. Do you understand the relationship between the pH and the conversion of acid to the ionic form, protonated to deproton? Basically, there is a deprotonation happening with the increase of pH. Okay. I hope this concept is clear to everybody. Let me know if you have any doubt. Write it in the chat box, or you can ask. Okay. I'll move to the next question. If you have any doubt, please let me know. Question number 3. During chlorination, with the rise in temperature of water, the death rate of bacteria, option A, increases, option B, decreases, option C, remains unaffected, and option D, none of the above. During chlorination, with the rise in temperature of water, the death rate of bacteria, options are A, increases, B, decreases, C, remains unaffected, and D, none of the above. Write your answers in the chat box. What would be the answer? This is a theoretical question. Why are you taking so much time? Okay. Okay, I can see 3 answers in the chat box. All of them are option A. What about others? Others also write your answers.
Ma'am,
Yeah,
ma'am, I have a doubt.
yeah. Ask.
Ma'am, when the temperature rises, usually the bacteria dies, but there are some bacteria which can survive a broad range of temperature. So, are we not considering those under this question?
So, if you read the question carefully, the question starts with during chlorination. So, we are generally talking about the bacteria that are present in the water samples. Chlorination is done for disinfecting the water. Okay, and in the water samples there are certain class of bacteria which are generally present in higher amount, and during the reason we are doing chlorination is to kill those bacteria. So irrespective of how resistant those bacteria are, uh, they are going to die eventually. So uh, I hope that clears your doubt. Like, even if you consider those bacteria, we are doing the chlorination process, and the chlorination will be done till the point all of them die. Okay.
Okay, ma'am. Thank you.
So, as her doubt uh, explains what should be the answer of this question, so option A is the correct answer, as you have written in the chat box. So, the death rate of bacteria increases because we are doing the disinfection of the sample during chlorination. So, during chlorination, we are trying to kill the bacteria, so the death rate will increase. Okay. So, chlorination is a process of adding chlorine or chlorine compounds such as sodium hypochlorite or calcium hypochlorite, which is bleaching powder, to disinfect uh, to disinfect the water, making it safe for drinking, swimming, and industrial use. And this method effectively kills the bacteria, virus, and other harmful microorganisms. Okay, we'll discuss more about chlorination, the mechanism, and all in the subsequent questions. Any doubt? If you have any doubt, please write it in the chat box. Moving on to the next question, question number 4. The normal dose of chlorine during post-chlorination is option A 0.5 to 2 ppm, option B 0.1 to 0.2 ppm, option C 0.8 to 1.5 ppm, and option D 1 to 5 ppm. Normal dose of chlorine during post-chlorination is. What would be the normal dose of chlorine during post-chlorination? Options are 0.5 to 2 ppm, 0.1 to 0.2 ppm, 0.8 to 1.5 ppm, and 1 to 5 ppm. All of you write your answers in the chat box. ppm means parts per million. I see 2 answers in the chat box. Both of them are option D. What about others? Anyone else wants to answer? Okay, let's see the correct answer. So, 2 people are saying option B. The correct answer is option D, 0.1 to 0.2 ppm. So, what do we mean by post chlorination? So, there are two terms, pre chlorination and post chlorination. So, this basically means there are two processes in the water treatment. Uh, Pre and post refers to what process we are doing before chlorination, or what process we are doing after chlorination. So basically, if we are doing filtration first and then chlorination at the end of the water treatment, it is called post chlorination. But if we are doing chlorination first and then we are doing the rest of the water treatment steps like filtration and other steps of water treatment, then though in that case it is called pre-chlorination. So pre and post chlorination basically means whether we are doing the chlorination before other steps of the water treatment process or after all the steps of the water treatment process. Okay, so now think logically, if we have to do chlorination at the beginning, we would need more amount of chlorine, right? Because the water is going to be very contaminated and we would need a lot of chlorine to clear out all the organic and all the organic material and the organisms, the live organisms, right? And if we are doing all the other steps of purification first, water treat not purification, water treatment first, and then at the end we are doing chlorination to remove the remaining organic matter, in that case we would need less amount of chlorine. So for post chlorination, that's why we need very low amount of chlorine. For if we do pre chlorination, we will need a lot higher amount of chlorine than uh, what we need for post chlorination. Okay, so 0.1 to 0.2 ppm, it's a very small amount of chlorine that is required if we are doing chlorination after all the water treatment steps. Is this clear? Is this clear to everybody? If you have any doubt, please
Yes.
let me know. Especially people who haven't responded, I hope this is clear to you now. Okay, let's move to the next question then. Question number 5. Hypochlorous acid dissociates through the following reaction. HOCl goes to H plus OCl minus. We discussed about dissociation of hypochlorous acid now. The dissociation constant is given Ka as 2.7 into 10 raised power of minus 8. Calculate the ratio of OCl minus concentration by HOCl concentration present at a solution pH of 2. So this is actually very easy to solve if you have solved the questions from first week session. First and second week session had questions like this. So dissociation constant of an acid is given. You have to find the ratio of OCl minus by HOCl concentrations at pH 2. So pH is given, dissociation constant is given, and you have to find the ratio. How will you do the calculation? All of you do this calculation and let me know the answer. Quickly do this calculation. Okay, I already see 2 answers in the chat box. What about others? Okay, for others, I'll give one hint that you are pH is given in this question. So pH is given as 2. So from pH, what we can solve, we can find the H plus ion concentration, right? And then you just uh, see how can we write the dissociation constant uh, in terms of the concentration of reactants and products for this reaction. I can see 3 people have already solved it. What about others? This is something we have studied 5 weeks ago, so all of you should be able to answer this. Quickly do the calculation, and the calculation is also not that difficult. Anyone else wants to answer? Okay. 3 people have answered in the chat box and all of them are saying option B. That is the correct answer. So you have the dissociation constant given here, Ka, and the dissociation constant can be written as the concentrations of the products. So here 2 products are there. So H plus concentration multiplied by OCl minus concentration divided by HOCl concentration, that is the reactant concentration. Okay, so now we have to solve for this, right? OCl minus concentration by HOCl concentration, and H plus ion concentration you can find from the pH. So pH is given as 2, so H plus ion concentration would be 10 raised to the power of minus 2. So this will be 10 raised to the power of minus 2. So your ratio would be Ka by 10 raised to the power of minus 2. So this is 2.7 into 10 raised to the power of minus 8. If you divide it by minus 10 raised to the power of minus 2, you will get 2.7 into 10 raised to the power of minus 6, which is option B. So the calculation is very simple. I told you H plus ion concentration from the pH you can calculate. So pH is equal to minus log of H plus ion concentration. So if pH is 2, this will be minus log of H plus ion concentration, and H plus ion concentration would be 10 raised to the power of minus 2, right? This is something we have studied in the first session also. So I hope this is clear to everyone. Only 3 people have given the answer. I hope who haven't written the answer in the chat box, they also got the correct answer. Anyone having any doubt in this question? Okay. If you have any doubt, please write it in the chat box. Meanwhile, I'll move on to the next question. Question number 6. Chlorine demand of water is equal to option A, applied chlorine, option B, residual chlorine, option C, sum of applied and residual chlorine, and option D, difference of applied and residual chlorines. Chlorine demand of water is equal to applied chlorine, residual chlorine, sum of applied and residual chlorine, or difference of applied and residual chlorine. What would be the correct answer? Again, 3 answers are there in the chat box already. What about others? Anyone else wants to write an answer? What is chlorine demand? Okay, the 3 answers in the chat box are option D, that is difference of applied and residual chlorines. That is the correct answer. So, what is chlorine demand? Chlorine demand is basically the amount of chlorine required to react with the impurities in water before a free residual chlorine level is achieved. So, basically, if we have a water sample, we will keep adding chlorine, and the chlorine will keep reacting with the organic matter, bacteria, ammonia, whatever contaminants, whatever impurities are present. It will keep reacting with these impurities, and slowly these impurities will react with chlorine and get removed from the water. So what will happen when we start adding chlorine? At that time, chlorine will be consumed by these organic matters. But after a point when all of these impurities have reacted, there will be no impurity left, and then free residual chlorine will start rising. Okay, the point where the free residual chlorine, after a point, we'll have some residual chlorine, and we'll know the initial amount of chlorine that we had added. So from that we can calculate the chlorine demand of a particular water sample. So if we have, let's say, we have given 2 mg per liter of chlorine dose to a water sample, and residual chlorine is 0.5 mg per liter, then we can say that the chlorine demand of that water, that the water sample or whatever sample we are using, that particular sample required 1.5 mg per liter of chlorine to be free of these impurities, for all the impurities present in if a water sample has a lot of impurities, the chlorine demand will be high. If the water sample has less impurity, the chlorine demand will be low. So understand it in that way. And there are certain factors that affect this chlorine demand. That those factors are amount of organic matter and or microorganisms. So like I said, higher amount of impurities will increase the chlorine demand. Ammonia and nitrogen compounds are also impurities, so they will also react with the chlorine, and higher amount of ammonia present in the water, higher will be the chlorine demand. Then you have pH levels. If you remember, I told you that the chlorine when added to water forms hypochlorous acid, and it has pH dependency on to which, how much hypochlorous acid can be present in the water. So hypochlorous acid is the main disinfectant that basically removes all these impurities. So presence of hypochlorous acids is highly dependent on pH, because after a certain point the hypochlorous acid will start converting into hypochlorite ions. So higher pH reduces the effectiveness of chlorine, because at higher pH more ionic form will be present and less of the acid form will be present. Okay, and acid form is the effective form of the chlorine. So it will reduce the effectiveness of chlorine, increasing the demand. So if the pH of the sample is high, you will need more chlorine to disinfect or to remove the impurities. Then it is also temperature dependent, and contact time is also a factor that affects the chlorine demand, because longer contact allows more reaction and thus it affects the demand. Okay, is this clear? What is chlorine demand and how multiple factors affect the chlorine demand? I hope that's clear to everybody. If you have any doubt, let me know. If you have any doubt, please write it in the chat box. I'll move to the next question. Question number 7. Oxidation of ammonia into nitrites is performed by option A, Nitrobacter, option B, Nitrosomonas, option C, E. coli, and option D, Rhizobium. Oxidation of ammonia into nitrites is performed by. What would be the correct answer? Write your answers in the chat box. Oxidation of ammonia into nitrites is performed by option A, Nitrobacter, option B, Nitrosomonas, option C, E. coli, and option D, Rhizobium. Okay, I see multiple answers in the chat box. All of them are option B. Anyone else wants to write the answer in the chat box? Okay, let's see the correct answer. Option B is the correct answer, nitrosomonas. So, conversion of ammonia into nitrites or oxidation of ammonia into nitrites, this process is called nitrification, and this is carried out by the bacteria nitrosomonas. We have other bacteria here, nitrobacter and rhizobium. They are also part of the nitrogen cycle. So, bacteria responsible for converting ammonia into nitrites are known as ammonia oxidizing bacteria, and a process is called nitrification process. And these bacteria oxidize ammonia or ammonium ions into nitrite using the oxygen in the following reaction. In this reaction, you can see ammonia is converted into nitrite. This nitrite can be further oxidized into nitrate, NO3 minus, and then nitrate can be uh, this nitrate then can be reduced to nitrogen. Okay, so this part of the process is called denitrification. So we have other bacteria, nitrobacter, that converts nitrites to nitrates. So this process is done by the bacteria nitrobacter. There are bacteria present in soil. This is rhizobium. It is mainly present in the soil and it fixes nitrogen to form ammonia. So if you see the nitrogen cycle, you have N2, you have NH4, you have NO2 minus, you have NO3 minus. So nitrogen to ammonia, this is called nitrogen fixation. This is called nitrogen fixation, and this is carried out by rhizobium. This is rhizobium. It is carried out by rhizobium, where rhizobium fixes the atmospheric nitrogen and makes ammonia. Then this ammonia is converted to nitrites by nitrosomonas, and nitrites are converted into nitrates by nitrobacter. And both of these steps are part of nitrification process. Okay, these two are combined, called nitrification. So this is basically oxidation reaction. Ammonia is oxidized into nitrite and then further oxidized into nitrate. So nitrosomonas performs the ammonia oxidation. It's called ammonia oxidizing bacteria, AOB. And nitrification and nitrite to nitrate oxidation is carried out by nitrobacter. These nitrates are then converted back to nitrogen. This process is called denitrification. This is a reduction process. This is called denitrification. Okay. So, and this is how the complete nitrogen cycle occurs in the in nature. Okay. I hope this is clear to everyone. If you have any doubt, please let me know. Anyone having any doubt? Okay. Moving on to the next question then. In fresh bleaching powder, the chlorine content is about. In fresh bleaching powder, the chlorine content is about option A 2 to 15%, option B 10 to 20%, option C 30 to 35%, and option D 45 to 55%. In fresh bleaching powder, the chlorine content is about 2 to 15%, 10 to 20%, 30 to 35%, and 45 to 55%. Write your answers in the chat box. Okay, I see option C given by 3 people. What about others? All of you write your answers in the chat box. What is the content, chlorine content in bleaching powder, fresh bleaching powder? Okay, 4 answers are there. All of them are option C. Let's see. The correct answer is option C, 30 to 35%. So bleaching powder is calcium hypochlorite. So till now we have been discussing about hypochlorite ions. So OCl minus is the hypochlorite ion. So calcium hypochlorite is commonly called bleaching powder, and it is widely used disinfectant. So I am pretty sure you must have, all of you must be familiar with bleaching powder. It is commonly used in households as well for cleaning the sinks and all. It is basically, it can remove stains because it has bleaching property. So even in textile industry, it is used for removing the color from a cloth piece. Okay, so bleaching powder, it is widely used as disinfectant because it can actually kill the bacteria present on a surface. So disinfectants are the chemicals that can be used to uh, reduce the organic uh, growth in, like, reduce the number of living organisms present on a surface. So if it is used on a inanimate or any non-living surface, it is called disinfectant. If we can use the chemical on our skin for disinfecting a wound, it is generally called antiseptics. So all the uh, solutions that we use to clean the wound, like Dettol, Savlon, all those are antiseptic liquids which are used to clean, with basically to kill the bacteria around the wound and to prevent the growth of any bacteria on the wound which can cause potential infection. Similarly, we mop the floors of our house and we clean the table surface. So all these surface are cleaned with certain chemicals which are disinfectants, which can remove the bacterial growth from the surfaces so that there won't be any potential growth and there won't be any chance of infection that can happen. So bleaching powder is one of such disinfectant, and the available chlorine content in the fresh bleaching powder is typically between 30 to 35%. When bleaching powder is dissolved in water, it actually releases the hypochlorous acid, which is the active disinfectant. That's why we have been discussing about hypochlorous acid so much, because a hypochlorous acid is actually the disinfecting agent. So when we do chlorination of water also for disinfection, in that case also final product that is forming is hypochlorous acid. So bleaching powder also has hypochlorite ion. If we dissolve it in water, it will form hypochlorous acid, and that hypochlorous acid actually acts as the disinfectant. It can kill the microorganisms present on a surface. So this is the reaction that happens. Bleaching powder dissolved in water, it will form calcium hydroxide and release chlorine, and these chlorine ions can react with water to form hypochlorous acid. Okay, and the release of calcium hydroxide is the reason, if you have experienced, when you dissolve bleaching powder in water, it becomes hot. The solution becomes hot because all these reactions release certain amount of heat. Okay, so hypochlorous acid is the active disinfectant that causes the disinfection and oxidation of organic matter. Okay, anyone has any doubt or any questions regarding this? Let me know if you have any question regarding this. Okay, meanwhile, we can move on to the next question. What is the oxidation state of nitrogen and glycine? The formula of glycine is given. It's an amino acid. What is the oxidation state of nitrogen in this molecule? Write your answers in the chat box. What is the oxidation state of nitrogen in glycine? No one knows the answer? You can calculate the oxidation state. I hope you have studied it in school. Okay, 3 answers are there. All of them are option C. Okay. What about others? Others also agree with option C, or they just don't want to answer anything, or they don't know? Come on. Everyone write your answers in the chat box quickly. What is the oxidation state of nitrogen in glycine? Okay, let's see the correct answer. 3 of you are saying option C. That is the correct answer. So glycine, it's a amino acid. So all the amino acids are written in the form of, you have one N which is attached to hydrogens, attached to the carbon, alpha carbon, and then you have the carboxylic group. So the carbon has a carboxylic group attached, amino group attached, and then since it's a glycine, the side chain is also H, so you have NH2, CH2, COH. This minus won't be there. Sorry. Yeah. So we have to find the oxidation state of this N. So now see, in this case, N is acting as electronegative compound because it is more electronegative than hydrogen and carbon. So what will it do? It will withdraw electrons towards it. So hydrogen has 1 electron, so this is +1. This hydrogen will also have +1, and carbon has 4 electrons, which is making 4 single bonds. So with this nitrogen, it is making 1 single bond, so it is giving 1 electron. So from this also we are getting, so carbon will have a +1 charge and nitrogen will get -1 charge from this hydrogen, -1 charge from this hydrogen, and -1 charge from this hydrogen. So 1, 2, 3. So total charge on nitrogen will become -3. So this is the oxidation state of nitrogen in glycine. Okay, so option C is the correct answer. Is this clear? Is this clear to everyone? If you have any doubt, please ask. I hope you understand how to calculate the oxidation state in case you did not know. Okay, good. So moving on to the next question, question number 10. Breakpoint chlorination of water involves the addition of sufficient amount of chlorine to option A, react with any ammonia and readily oxidizable matter present in water. Option B, kill the Giardia cyst present. Option C, react with ferrous ions only. Option D, reduce the growth of bacteria and filters. Breakpoint chlorination of water involves addition of sufficient amount of chlorine to Option A, react with ammonia and readily oxidizable matter present in water. Option B, kill the Giardia cysts present. Option C, react with ferrous ion only. And option D, reduce the growth of bacteria in filters. What would be the correct answer? What is breakpoint chlorination of water? Write your answers in the chat box. Yes, do you have any question, Titli? Okay, I already see two answers in the chat box. Option A, react with ammonia and readily oxidizable matter. Anyone else wants to answer? Okay, three answers are there. All of them are option A. What about others? Write your answers in the chat box and then we'll have the discussion. Okay, let's see the correct answer. So you are saying option A, react with ammonia and readily oxidizable matter present in the water. That is the correct answer. So breakpoint chlorination, or as I have already explained when explaining chlorine demand, that when you do the chlorination of water, initially the chlorine will immediately start reacting with the organic matter present in the water and it will be consumed. Okay, after a point when all the organic matter are have reacted, what will happen, the residual chlorine will start emerging in the reaction, and then the residual chlorine, the free chlorine, will start increasing. So the point where this change in the chlorine concentration from decrease to increase, the switch occurs, that point is called the break point, and the process is called breakpoint chlorination. And it that break point is achieved till all the ammonia and other oxidizable organic matter have reacted with the chlorine. Okay, so see, ammonia can react with chlorine, then form nitrogen, that is reduced to nitrogen and 6HCl. Then it can also form nitric acid. Organic compounds can react with chlorine to form trihalomethanes, where halogen will get this chlorine, which is the halogen, it will get attached to the organic compounds. So organic compounds are composed of CH carbons and hydrogens, right? So they can attach to the halogen can attach to the organic matter after the organic matter has decomposed, and then it can form multiple trihalomethanes, which is the basically which will then be removed from the water. Okay, so this is breakpoint chlorination. I hope this is clear. If you have any doubt, please let me know. Moving to the next question, question number 11. THMs are produced in the drinking water during chlorination. The THMs are Option A, acidic in nature. Option B, alkaline in nature. Option C, carcinogenic. And option D, complexing agents. THMs are produced in the drinking water during chlorination. The THMs are option A, acidic in nature. Option B, alkaline in nature. Option C, carcinogenic. And option D, complexing agents. I've told you what THMs are, trihalomethanes, right? So, what is the nature of trihalomethanes, whether it is acidic, alkaline, carcinogenic, or they act as complexing agents? What is the correct answer? Write your answers in the chat box. Okay, I see 3 answers in the chat box. All of them are option B, alkaline in nature. What about others? Anyone else wants to answer? Okay, let's see the correct answer. The correct answer actually is option C, carcinogenic. So, alkaline at higher pH or at alkaline pH, the production of trihalomethane is more probable, but the THMs in itself are not alkaline in nature. Okay, so if this water sample is alkaline, then when we do the chlorination, there's a chance of formation of more and more THMs. But THM in itself, they are not alkaline in nature. They are actually carcinogenic. Carcinogenic means it can cause cancer. So that's why removal of THMs from the water sample is very important. So molecules that can have the potential to cause cancer are called carcinogenic molecules, and THMs are one of them. Okay. I hope that's clear. Moving to the next question, question number 12. In iodometric titration, method using sodium thiosulfate as titrant and starch as the indicator, the endpoint is determined through the appearance of. Iodometric titration method using sodium thiosulfate as titrant and starch as indicator. The endpoint is determined through the appearance of. Options are pink color, option B blue color, option C red color, and option D yellow color. Pink, blue, red, and yellow. What would be the correct answer? Iodometric titration method using sodium thiosulfate as titrant and starch as indicator. What is the endpoint color? Pink, blue, red, and yellow. What would be the right answer? Write your answers in the chat box. Anyone? Yeah, I see 2 answers. What about others? All of you write the answers. Okay, 4 of you have answered option B, blue color. Anyone else wants to write the answer? Okay, let's see the correct answer. Option B, blue color is the correct answer here. So, what happens during iodometric titration? So, this titration is basically done to determine the amount of chlorine present in the water, to determine the residual chlorine. Okay, so remember during the chlorination process and when we discussed about chlorine demand, we saw that there is a point after which free residual chlorine is present, starts increasing in the water sample. So if we have taken a water sample of which we have done the chlorination, now we want to determine the residual chlorine concentration so that we can calculate the chlorine demand, right? So how will we calculate the residual chlorine concentration? For that we do iodometric titration, where uh, the free chlorine and the chloramines that are present, they will quantitatively release iodine. So free chlorines will react with iodide ion to release iodine. So you can see one molecule of chlorine is releasing one molecule of iodine. Here one molecule of hypochlorous acid is releasing one molecule of iodine. So we can quantitatively determine if we quantify the amount of iodine released. So what we do, normal titration process, I hope all of you are familiar. So we, whenever we are doing a titration, we have a flask in which our uh, sample is present along with few drops of indicator. In this case the indicator is starch. So starch will be added and our water sample will be there, whose uh, chlorine concentration we want to determine. Okay, now we will take the burette, from which drop by drop we will start adding sodium thiosulfate. Okay, so sodium thiosulfate, that is S2O32 minus ions, thiosulfate ions will be added to this sample containing the starch. uh, so the iodine that will be released from all these chlorines and all these chlorine and chloramine compounds, these iodine will start reacting with the sodium thiosulfate ions to again get converted to iodide ions. Okay, so now when you add starch to iodine, what happens? It gives a blue black color. Okay, so it's a very common reaction. Starch and iodine gives a blue black color, which is used in multiple reactions. So in this case also we will do that, and the amount of sodium thiosulfate that will be added to the sample to see the blue black color that is appearing due to the iodine and starch reaction, that amount will directly correspond to the amount of iodine present, and that amount of iodine will directly correspond to the amount of chlorine present. Okay, so that's how we determine the residual chlorine concentration in the sample. So this is how we do iodometric titration, and the appearance of blue color that is appearing because of the presence of starch is the end point of the titration. Is this clear to everyone? If you have any question, please ask. If you don't have any question, I'll move to the next question. Question number 13. If the chlorine dose applied in the water sample is 1.5 mg per liter and the chlorine demand of the water is 1.3 mg per liter, what is the residual chlorine concentration? Chlorine demand is given as 1.3 mg per liter. Dose is given as 1.5 mg per liter. Then what would be the residual chlorine concentration? Options are 0.2 mg per liter, option B 2 mg per liter, option C 20 mg per liter, and option D 0.02 mg per liter. What would be the correct answer? There's not a lot of calculation that needs to be done here. I already see 2 answers in the chat box. What about others? All of you write your answers in the chat box quickly. I have explained what chlorine demand is. In one of the previous question, I have already discussed what chlorine demand is. All of you should be able to answer this question. I want answers from everyone. Write your answers in the chat box quickly. Okay. 5 people have answered option A, 0.2 mg per liter. Let's see the correct answer. So chlorine demand, I told you chlorine demand is defined as the chlorine dose minus residual chlorine, right? Chlorine demand is written as chlorine dose subtracted by residual chlorine. Okay, so chlorine demand is given as 1.3 mg per liter, chlorine dose is given as 1.5 mg per liter, and residual chlorine is what we have to determine. So residual chlorine will be equal to 1.5 minus 1.3, that is 0.2 mg per liter. That is option A. That is the correct answer. So chlorine demand is basically the amount of chlorine required to remove all the organic matter and all the impurities from water. So how do we define that? We basically apply certain amount of chlorine, that is the chlorine dose, and then we, after all the impurities have been removed, we determine the residual chlorine, and that residual chlorine, if we subtract it from the dose, we will get the chlorine demand. Okay, that means that water sample requires 1.3 mg per liter of chlorine to remove all the impurities from the water. Okay, so option A, all of you answered. That is the correct answer. So this is the detailed solution. Anybody has any doubt in this, please let me know. Okay. If there's no doubt, then I can move to the next question. Question number 14. You are titrating iodine with sodium thiosulfate. The molecular weight of sodium thiosulfate is m. Its equivalent weight will be option A m by 2, option B 2m, option C m, and option D m by 4. What is the equivalent weight of sodium thiosulfate if the molecular weight is m? Options are m by 2, 2m, m, and m by 4. What would be the correct answer? All of you write the answers in the chat box. What would be the correct answer? If the molecular weight of sodium thiosulfate is m, then what is the equivalent weight of sodium thiosulfate? What would be the correct answer here? Write the answers. Okay, I have option C in the chat box. Let's see the correct answer. Option C, that is M, that is the correct answer. So sodium thiosulfate, in that iodometric reaction, I've shown you what the iodometric reaction is already in the previous question. So in this reaction, sodium thiosulfate is oxidized into tetrathionate, and iodine is reduced to iodide ions. So the reaction actually occurs together. So when sodium thiosulfate reacts with iodine, what happens is sodium thiosulfate is oxidized to tetrathionate, and 2 electrons are released. These 2 electrons are given to iodine to form iodide ions. Okay, so 2 electrons are involved per molecule of per 2 molecules of thiosulfate. So that means one molecule of thiosulfate is going to release 1 electron. So that means the equivalent number is equal to 1. So whatever the number of electrons, if one molecule was releasing 2 electrons, then the equivalent number will be 2 electron per molecule. Okay, so in that case, the equivalent number would have been 2. Okay, so here 2 electrons per 2 molecule, that means 1 electron per molecule. So that is equivalent number is 1. So molecular equivalent weight is equal to molecular weight by equivalent number. So m by 1 is m. So equivalent weight of sodium thiosulfate is equal to the molecular weight of sodium thiosulfate. Okay. Does anyone have any doubt in this? Let me know if you have any questions. Moving on to the next question, question number 15. You are performing the oxidation of ammonia or ammonium salts to produce nitrites or nitrates. The process is called. You are performing the oxidation of ammonia or ammonium salts to produce nitrites or nitrates. This process is called option A, disproportionation, option B, denitrification, option C, nitrification, and option D, decomposition. Oxidation of ammonia or ammonium salts to produce nitrites or nitrates. What is the process called? Options are disproportionation, denitrification, nitrification, and decomposition. I have actually told this in one of the previous questions, so most of you should be able to answer. I see many answers in the chat box. Okay, most of you are answering option C, that is nitrification. Okay, I'm happy that all of you have answered this question. C, nitrification is the correct answer. So if you remember, I've explained this already. I'll explain it once again. So we have nitrogen, ammonia or ammonium ions, nitrites, and then nitrates. So the process of conversion of ammonia to nitrites and nitrates, this process is called nitrification. Okay, this process is called nitrification. The process of conversion of nitrates to nitrogen, this is a reduction reaction. See, this is a reduction reaction, and this process is called denitrification. Okay, denitrification. And the process of nitrogen to ammonia conversion is called nitrogen fixation. Okay, so this is a part of nitrogen cycle. So here the question asked ammonia oxidation to nitrites and nitrates, this is called nitrification. If you remember from the previous question, what was the bacteria that was catalyzing this first step, ammonia to nitrite? It was Nitrosomonas. And what was the bacteria that was converting nitrites to nitrate? It was Nitrobacter. Okay, so you should remember the process and the examples of bacteria that can perform these reactions. Okay, so the other options that are there, disproportionation reaction, denitrification I've already explained, and decomposition reaction. Let's see what those are. So disproportionation reaction basically is the distribution of one molecule into its two different oxidation states. So here, in this reaction, nitrogen dioxide NO2, when reacts with water, forms nitric acid and nitrous acid. So here if you see the oxidation state of nitrogen, here the oxidation state of nitrogen is +4. How do we know that? Oxygen has uh, -2 charge. So 2 oxygen means -2 into 2, that is -4. So nitrogen will be +4 because the overall charge on this molecule is 0. So x minus 4 is equal to 0. So x will be 4. And after the reaction we are getting two compounds containing nitrogen. Now we will see the oxidation states of nitrogen in each of these. So for nitric acid, the oxidation state would be, so from hydrogen we have +1 plus X, because we don't know the oxidation state of nitrogen, and then plus 3 into -2, that is oxygen's charge, and all of this will be 0. So this will be -6 plus 1, that is -5. So x minus 5 is 0. So x will be equal to 5. So the oxidation state of nitrogen and nitric acid is 5. Oxidation state of nitrogen and nitrous acid would be, again let's calculate, +1 plus x plus there are 2 oxygens, so 2 into -2, that means -4. -4 plus 1 would be -3. This is equal to 0. So x minus 3 is equal to 0. So x is equal to 3. So the oxidation state of nitrogen and nitrous acid is +3. Oxidation state of nitrogen and nitric acid is +5. So from a +4 oxidation state, it got distributed in two molecules having two different oxidation states, that is +5 and +3. So this is called a disproportionation reaction. There are other examples also. You can take any metal ion which d block metal ions like copper. Copper, you know, it is in it can occur in Cu2 plus form, Cu plus form, and copper in Cu0 form also. So sometimes it happens that Cu2 plus can get disproportionate, sorry, Cu plus can disproportionate into Cu2 plus and Cu0 form. So there are multiple examples like that. Okay, so I hope all of you understood what disproportionation reaction is. In decomposition reaction, it is basically the molecule is decomposing into decomposing down into further smaller molecules. So we have nitrogen dioxide, it gets decomposed into nitric oxide and oxygen, and nitric acid can get decomposed into nitrogen dioxide, oxygen and water. So basically it is simplification of molecule as we go ahead. Okay, so decomposition, by the name itself you can understand decomposition means breakdown. So the molecule is breaking down into simpler forms. Okay, so nitrogen dioxide becomes nitric oxide, nitric acid becomes nitrogen dioxide. So it is it is basically breaking down into simpler compounds. And denitrification I've already explained, that is conversion of nitrates into nitrates back to nitrogen. So if you see the oxidation states here, what is the oxidation state of nitrogen in the nitrate? Can anyone answer the oxidation state of nitrogen in case of nitrates? NO3 minus. What would be the oxidation state of nitrogen? Can anyone write in the chat box? What would be the oxidation state of nitrogen in case of NO3 minus? Do you know how to calculate? I just told you how to calculate oxidation state. What would be the oxidation state of nitrogen in NO3 minus? Anyone? Okay, here also I'm getting two answers. Plus 5 and minus 1. Plus 5 is the correct answer. How did you get minus 1? Let's see how to calculate the oxidation states. So we have oxygen, 3 molecules of oxygen. So I told 3 atoms of oxygen. So I told you oxygen has minus 2 charge. So minus 2 into 3, that would be minus 6. And let's take the oxidation state of nitrogen as X. So this will be now equal to minus 1, not 0, because the charge is minus 1. Here the charge was 0, that's why we were taking 0. Okay, so this will be minus 1. So X minus 6 is equal to minus 1. So X will be equal to minus 1 plus 6, that is 5 or plus 5. Okay, so the oxidation state of nitrogen would be plus 5. Okay. I hope this is clear. So similarly, if you calculate the oxidation state of nitrogen in nitrite, it would be minus 4. X minus 4 is equal to minus 1. So X will be equal to plus 3. So now the oxidation state of nitrogen and nitrate was plus 5. Oxidation state of nitrogen and nitrite is plus 3. If you see in nitric oxide, that is NO, here it will be plus 2. If you calculate the oxidation state of N2O, you will find O is minus 2. So 2x minus 2 is equal to 0. So X will be equal to 1. So the oxidation state here is plus 1 and the oxidation state here is 0. So you can see the oxidation state is decreasing from plus 5 to 0. So this is a reduction process. Denitrification is a reduction of nitrogen. Okay, reduction of nitrogen from most oxidized form, that is the nitrate, to the least oxidized form, that is to the reduced form, that is the nitrogen gas. Okay, so this is denitrification is the reduction process, and the nitrification that we studied, these are the oxidation process. This is just the opposite of denitrification, where ammonia has minus 3 oxidation state of nitrogen. So from minus 3 we are reaching to plus 3 and then plus 5. So this is an oxidation process. Okay, I hope this is clear to you, the whole nitrogen cycle and the nitrogen chemistry. This is the most important part of this session's topic, so this should be clear to everybody. Anybody has any doubt in this? I can explain uh, the parts again. If you have any doubt in any of the parts, let me know. Any questions regarding this? Okay. If you have any question, please let me know. I'll move to the next question till then. Question number 16. In an experiment, a concentration of 0.1 gram per meter cube of free available chlorine affects 99% kill of bacteria in 8 minutes. Calculate the disinfection rate constant. So in an experiment, 0.1 gram per meter cube of free available chlorine affects 99% kill of bacteria. It is basically killing 99% of bacteria in 8 minutes. So what is the disinfection rate constant? You have to do the calculation here. Options are option A 4.576 per minute, option B 5.756 per minute, option C 7.756 per minute, and option D 6.576 per minute. Do this calculation if you know the formula and write your answers in the chat box. Okay, I have one answer in the chat box already. Very good. Option B. Okay, 3 of you are saying option B. So let's see the formula first. So to solve this, we'll use the formula n is equal to n0 e raised to the power of minus k c t, where t is time. So t is here, t is given as 8 minutes. C is the concentration of the free available chlorine. So that is given as 0.1 gram per meter cube. K is what we have to calculate. So K is the disinfection rate constant. K is the disinfection rate constant. Then N0 is the initial number of bacteria. Initial number of bacteria, and NT is, or N, let's write it as NT. So NT is the number of bacteria at time T. Number of bacteria at time T. So now here it is saying 99% of bacteria killed in 8 minutes. So at time T, let's say the initial number of bacteria was 100. Then at time T, the number of bacteria remaining would be 1, because 99% have died. So only 1 is remaining. So if total number was 100, then 99% of 100 would be 99. 99 has died. So NT would be 1 and N0 would be 100. Is this clear? So now you can replace all these values here. So you will get NT would be 1. So 1 divided by 100 is equal to e raised to the power of minus kct, and then you can take the log to solve the question, or you can use your calculators. So this is the formula, and the answer that you are getting is option B. That is the correct answer, 5.756. Yes. So I see 4 of you have gotten this answer. So I hope others who haven't answered, you understand the solution now. Anyone has any doubt in this question, or do you have any question regarding this? Please ask if you have any doubt. I hope this is clear to everyone how to solve this question. Okay, let's move on to the next question then. Anyone wants to ask anything regarding this? Okay, moving on to the next question. Question number 17. Which of the following is correct order of disinfectants arranged according to their increasing order of disinfection power? Which of the following is the correct order of disinfectants arranged according to their increasing order of disinfection power? Option A, ozone is the least disinfectant agent, then HOCl, then monochloramines, and then NCl3. Option B is ozone, then NCl3, then monochloramines, and then HOCl. Option C is NCl3, HOCl, monochloramines, and then ozone. And option D is NCl3, then monochloramines, then HOCl, and ozone being the most powerful. What is the correct answer here? Write your answers in the chat box quickly. Okay, I see a lot of answers in the chat box. All of them are option D, NCl3, monochloramines, HOCl, and ozone. That is the correct answer. That is the correct answer. So NCl3, then monochloramines, then HOCl, then ozone. This is the order of increasing order of disinfection power of these compounds. So basically, as we decrease the amount of chlorine, the disinfection power increases. So HOCl is commonly used disinfectant. I have explained it already. Ozone is having the most uh, highest power of disinfection among all these. Then comes HOCl, then comes monochloramines, and the least powerful disinfectant is NCl3, that is nitrogen trichloride. Okay. I hope this is clear. So trichloroamine would have the least disinfection power, and ozone will have the highest disinfecting power. Okay. Any question regarding this? Moving on to the next question. Rural water supply scheme serves a population of 10,000 at the rate of 50 liter per capita per day. For the chlorine dose of 2 ppm, what will be the required amount of bleaching powder with 20% available chlorine? So you have to calculate the amount of bleaching powder that has 20% of available chlorine. So first you have to calculate the chlorine demand, and then you have to calculate the amount of bleaching powder required, knowing that only 20% of available chlorine is present in that bleaching powder. So the water supply rate is given, total population number is given, chlorine dose is given. So calculate the amount of bleaching powder required. All of you calculate this and write your answers in the chat box. Okay, I already see answers in the chat box. What about others? All of you calculate and write your answers. I have 4 answers here. What about others? Okay. Okay, all of you are answering option B, that is 5 kg. Let's see if that's the correct answer or not. That is the correct answer. So, how will we solve this? So, the population number is given as 10,000, okay? And the water supply rate is given as 50 liters per capita per day. So, first we'll calculate the water supply for the whole population. Since it is given in per capita, if we multiply it with the population number, we will get the total supply for the whole population. So total supply would be 50 into 10 raised power 4 liter per day. Okay, or 5 into 10 raised power 5 liter per day. Now, since our chlorine dose is given in ppm, we'll convert this into meter cube. So this will become 5 into 10 raised power 2 meter cube per day, the total supply. Now our chlorine dose is given in ppm, so 2 parts per million. So that means 2 into 10 raised power minus 3 kg per meter cube. This is just the conversion from ppm to kg per meter cube. 2 into 10 raised power minus 3 kg per meter cube is the chlorine dose. Now, amount of chlorine required per day would be, so total supply is 5 into 10 raised power 2, and the chlorine dose is 2 into 10 raised power minus 3. So 2 into 10 raised power minus 3 kg per meter cube is required. So for 1 meter cube, 2 into 10 raised power minus 3 kg of chlorine is required. So for these many meter cubes, how many, for these many meter cubes, 5 into 10 raised power 2 meter cubes, how much chlorine will be required? It will be 2 into 10 raised power minus 3 multiplied by 5 into 10 raised power of 2 kg. So that comes to 1 kg. Okay, so 5 2s are 10, and then here minus 3 plus 2 would be minus 1. So 10 into 10 raised power minus 1 would be 1. So amount of chlorine required per day would be 1 kg. Now in the question it was given as the amount of bleaching powder with 20% available chlorine. So if 1 kg is what we require, so we need, let's say, uh, x kgs of bleaching powder, and the 20% of that x should be equal to 1. So x would be equal to 100 by 20, that is 5 kgs. So the amount of bleaching powder that is required would be 5 kgs. Okay. So option B, all of you have answered option B. That is the correct answer. So people who haven't answered, I hope this explanation is clear. If you have any doubt, even the people who have answered, if you have any questions regarding this, please ask. If you don't have any question, then I can move to the next question. Question number 19. What is the remaining percentage of pathogen after 1 minute of contact time during chlorination? What is the remaining percentage of pathogen after 1 minute of contact time during chlorination, assuming K is equal to 0.046 per minute? So you have to find the percentage of remaining pathogen after 1 minute of contact time, and K is given. How will you solve it? All of you calculate and write your answers in the chat box. I see 2 answers in the chat box. Others also calculate and write the answers, and then we'll have the discussion. Okay, I see multiple answers. All of them are option B, that is 95.5%. Let's see if that is the correct answer or not. That is the correct answer. So this is also similar to the one of the previous question that we had solved. So NT is the final amount of bacteria, NC is the initial amount of bacteria, and e raised to the power of minus k into t. K is already given in the question as 0.046. T given in the question as 1 minute. So you just have to solve uh, the ratio of NT by N0. If you find the ratio of NT by N0, basically you will get the percentage. So it is coming as 0.955. If you multiply it by 100, you will get 95.5%. Okay. Is this clear to everyone? If anyone has any question or any doubt, please ask. Okay, if there's no doubt, then I can move to the next question. Question number 20. Which of the following statement is correct? Options are: option A, pre-chlorination minimizes the formation of THMs. Option B, the substances used for disinfection of water is known as coagulant. Option C, chloramines are known as free chlorine residual. And option D, all of the above. Which of the statement is correct? Pre-chlorination minimizes the formation of THMs. Substances used for disinfection of water are known as coagulant. Chloramines are known as free chlorine residuals. And option D is all of the above. Write your answers in the chat box. This is the last question of today's session. Quickly write your answers and then we can end this session. Okay, I see 3 answers as option A, 1 as option D. Others also write the answers. Okay, I see 1 option C also. Anyone else? Anyone else wants to answer? Okay, the correct answer is option A. Pre-chlorination minimizes the formation of THMs. So I explained what pre and post chlorination is in the beginning of the session. So pre-chlorination means we are doing the chlorination at the beginning and then we are doing the rest of the water treatment steps. And post chlorination means first the filtration and other water treatment steps have been done, and then then chlorination is being done. So when we do pre-chlorination at the beginning, at the starting stage only, it minimizes the formation of THMs, because at the end process, like at the beginning process only, we will reduce all the organic matter that is present in the water. Okay. The substances used for disinfection, they are called disinfectants. Chloramines, they are not the free chlorine residuals. Free chlorine residual, I have explained, when we do chlorination, the amount of chlorine that is remaining after the removal of all the impurities, that is the free residual chlorine. Chloramines are basically chlorines. When they react to amines, they form chloramines like NCl3 or NHCl2, like that. Okay. So pre-chlorination minimizes the formation of THMs. That is the correct answer. With this, we come to the end of the session. If you guys have any doubt, please let me know. Anyone has any doubt regarding any of the questions discussed today, or any other question related to the topics uh, that are there in fifth week session? Any question related to nitrogen chemistry or chlorination process? Everything is clear then? Anyone has any doubt? Okay, if there's no doubt, then I can end this session today. Thank you all for joining.
Thank you, ma'am.
Yeah, thank you for joining. And if you have any doubt, you can ask me in the next session also. See you next Tuesday. Okay? Okay, I'll close the session now. Thank you. Bye bye.